Fabulous chemistry faithful, video 5. Today we're going to get into enthalpy in table I. This is going to be a review lesson. So be able to read and interpret the heats of reaction, which we learned how to calculate now using the potential energy diagrams. It's always the products minus the reactants. Always goes products minus reactants. Okay, so let's get right into it. Reading table I. The delta H of the reactions is the sum of all the energy absorbed to break the reactants' chemical bonds to form the activated complex, and then the energy released when forming the new chemical bonds in products. I like this long, dragged out thing. This gives us a little bit more information about what's really going on and kind of what that activated complex is. This is the equation for calculating all delta H's. It's the heat of the products minus the heat of the reactants. That heat is the potential energy. Okay. That heat is not the kinetic energy. It's the stored chemical energy. Okay. The magnitude of delta H tells us how much energy is involved. Magnitude means how big the number is. So if I have two reactions that are exothermic, one releases 100 kilojoules of heat and the other one releases 1,000 kilojoules of heat. They're both negative because they're exothermic. The sign determines if the energy is released or absorbed. Released would be exothermic, exiting, releasing, giving off. Magnitude talks about the size of the number. 1,000 is much bigger than 100, so that's pretty easy. Okay, we just got to make sure we know that. And then what we learned in our previous learning was if you double the reaction, you double the amount of heat. Perfect. And let me guess what it's about to say. If I half the reaction, then I half the amount of heat. Oh, look, that's what it does say. See? So this is part of a different unit we did when we did physical behavior of matter, I believe. And so we're just going to revisit it and make sure you know how to do it. Okay, reversing a reaction. Ooh, if I go backwards. So this is the fun part. Now that we actually know what forward and reverse reactions we're talking about, we're getting a little bit more familiar with that. When they run in the reverse order, we have to flip the sign. Okay. Negative heat values become positive. So an exothermic becomes endothermic. Oh, there we go. See? And then a positive heat becomes negative. So then an endothermic becomes exothermic. And this is just helping us read those graphs that I can go backwards or forwards. And then we have a little bit of stuff. Let's see if it's animated. Oh, good, it is. So if I look this up, N2 plus 2O2, right? It's endothermic because it's positive, and I believe this is reading it straight up. Next one, I look up in the reference table. This is table I, by the way. I mean, I can grab one, show you guys what I'm talking about. Sorry, I started talking in the video and my nose started getting stuffy, so I apologize. Table I, page 5. This guy here, I'm going to find N2, H2. See some N2s. Those aren't what I'm looking for. N2 to H with an H2. N2 with an H2, found it. Negative 91.8. Negative's exothermic. And then this next reaction is the exact same reaction, but notice it's flipped. The product is now on the product side. I'm pointing at the screen like you can see what I'm saying. Let me do it like this. The product is now on the reactant side. It's flipped. And then the reactants here are now on the product side. That's what I mean by flipping the reaction. If I flip the reaction, the number is going to be the same. I'm just going to flip the sign. There you go. Quick review of an old lesson. And let's see if there's more to do with this or if it's just really just review. Ready? And that's it. Just another review lesson. And you guys now know a little bit more about table I and hopefully reinforce the stuff we already learned. And we're moving right on to the next one. See ya.